Please pause this video, attempt this question, post your answers if you know it down there, or if you don't, just say I don't know. And if you can, like the video, it helps out that algorithm. So pause this video now. So in this question, describe how steam is used to generate electricity. Well, what we do is we do this nuclear reaction to get heat. And the heat turns the water into steam, water vapor, which turns turbine. And the turbines look like this. So this is a picture of a turbine. As you can see, the turbine has magnets. Now, you don't need to mention this, but it's good to know because it comes up in your GCSE for magnets. And whenever you've got a moving magnet within a coil of wire, so there should be coiled wire right over there, and you've got some magnets moving within it, it induces a voltage. And that is literally how you generate electricity, by moving a bunch of magnets in. But the answer they wanted was steam, which turns a generator, and the generator generates electricity. But that is really how it goes. Question B, describe how a fission of uranium-235 can start off a chain reaction. You may draw a diagram to help with this. Now, this is the diagram they're looking for. So what you start off is uranium-235, the nucleus of uranium-235, and you fire a neutron at the nucleus of uranium-235. Now, when the neutron enters the nucleus of uranium-235, it makes it unstable because the neutron doesn't belong there. And when it becomes unstable, it splits into two daughter nuclei. Daughter nuclei meaning it's from that and then two daughter nuclei. It releases a bunch of energy and two or more neutrons. Okay. Now, these other neutrons then collide with other uranium-235, and that starts a chain reaction. So you've literally started with one, you've got three over there, and these split up even more. So you've got nine over here, you've got maybe 12 over there, and blah, blah, blah. It's going out of control. This is why sometimes you have control rods, which absorb some of the neutrons, because you don't want too many neutrons flying about, hitting too much uranium-235 in one go, creating an immense amount of energy, which will lead to an explosion. So the answer they were looking for is the neutron hits the nucleus of uranium. Do not say the atom, the nucleus of uranium, producing more neutrons, you could say two or more. At least one neutron can hit another uranium nuclei. That's the answer they were looking for. One of the products is a fission of this. Which of the products are they? Okay, so basically, you started with uranium-235. All of a sudden, you've now got 142, okay? And this is where it gets really, really interesting. Now, you can't just lose mass. So what happens is you do 142 minus the 235. So you minus the two numbers from each other, 93, okay? So you should have something 93, but I said to you before, okay, there's two or more neutrons given out. So that 93 is actually probably going to be 91, plus you got two neutrons that fly away and they hit other uranium-235. Explain what happens when the beta radiation ionizes. So whenever something ionizes, that means it removes electrons. Okay, so you've got an atom over here. It has the electron number is the same as the proton number. When you give it enough energy, the electron can escape. And when the electron escapes, the atom has lost electrons and it becomes positively charged. It becomes an ion. It has ionized, and that is what happens. The atom has become a charged particle, either a positive charge in this case because it's lost an electron. Explain why large amounts of energy are needed to make a fusion reaction. Well, a fusion reaction looks like this. Now, what you can see in a fusion reaction is you're trying to join up two positive nuclei. The nucleus is positively charged. And we're using hydrogen because it doesn't have a bunch of protons, so you don't need as much energy to join these up together. And because you're trying to fuse together two nuclei that are positively charged, there's a repulsion force trying to push it away. And what you're going to do is you're going to supply so much heat and pressure, but in this case, they're talking about heat. So you need enough heat to overcome the repulsion force that is trying to put it together, push it apart. So the nuclei is positively charged. That's what they're looking for. And it needs enough energy to overcome the repulsion, okay? Except same charge, the protons in the nuclei, except atoms. I wouldn't use the word atoms. I wouldn't say the atoms are trying to join together because then you're kind of like mixing the electrons and blah, blah, blah. You're just focusing on the nuclei. That is it. And that is why you need high enough temperature to do that, so that they have enough kinetic energy, enough energy to overcome the repulsion force. And that is that. So subscribe to this channel. I post GCSE, science, and math videos solved. Thank you, take care, and bye-bye.